Welcome to this explainer. Okay, I am absolutely thrilled you're joining me today because we're going to unlock what might literally be the ultimate math shortcut for real-world percentage problems. If you've ever felt completely bogged down trying to calculate taxes, figure out discounts during a sale, or, track changing interest rates, well, you are definitely in the right place. Today, we're mastering Unit 10.2 using a multiplier. This is a super simple, highly efficient tool that's going to completely change how you handle numbers from here on out.
So, here is our quick agenda for today. 1. The percentage problem. 2. The baseline. 3. Percentage increases. 4. Percentage decreases. And finally, 5. The multiplier formula. All right, let's dive right in.
Section 1. The percentage problem, a tedious task. Let's talk about why the way we learned this stuff in school can be so incredibly frustrating. I want to ask you a very direct question. Is there a faster way to calculate percentages? Think about a typical problem. Say you want to increase $275 by 65%. Now, the traditional method tells us to first find 65% of 275, which is $178.75. Then we have to take that number and add it all the way back to our original 275 to finally get our total of $453.75. Calculating the percentage change and then adding or subtracting it from the original, it just takes way too many manual steps. And honestly, unless you actually enjoy doing extra homework at the checkout counter, we really need a better way.
Let's compare that tedious two-step method to our magical one-step shortcut. Instead of calculating a piece of a number and then awkwardly gluing it back on, we have a direct path. Original value times the multiplier equals the new value. It's almost like a math expressway. But how do we actually find that multiplier?
Section 2. The baseline, establishing 100%. The golden rule right here is 100%. It absolutely does not matter what you're calculating, whether it's the cost of a $2,300 flight or the price of a $275 item in a shop. That original value is always your starting baseline of 100%. The crucial point here is that your original value represents your perfect, untouched 100% starting point. If a value goes up, it goes above 100%. If it goes down, well, it drops below. It really is that simple. And getting a firm grasp on this baseline is exactly what makes the entire multiplier method possible. Section 3. Percentage increases, calculating growth. Okay, let's walk through the logic here step by step, nice and easy. Remember our earlier example of a 65% increase? Step 1, you start at your baseline of 100%. Step 2, you add your increase to that baseline. So 100% plus 65% gives us 165%. Step 3, you simply convert that new percentage into a decimal by dividing by 100. So 165% becomes 1.65. And there it is. That number, 1.65, is your multiplier. Just look at the power of this single step. Instead of finding 65% first and then adding it on, we do it all in a single, elegant calculation. We just take our original value of $275 and multiply it by 1.65. Bam! $453.75. We get the exact same answer as the tedious two-step method, but we arrive there instantly. So, formally speaking, what is a multiplier? It's simply a decimal derived from converting a percentage. We use it to multiply a base value and adjust it in one seamless step. It completely streamlines your calculations, totally removing the need for all that repeated manual addition or subtraction. It's a real game changer. Section 4, percentage decreases, calculating drops. Now we're going to carefully trace that exact same logic, just in reverse. Let's say we want to decrease our $275 item by 54%. Step 1, we start at our 100% baseline. Step 2, because it's a decrease, we subtract. So 100% minus 54% leaves us with 46%. Step 3, we convert that 46% to a decimal, giving us an instant multiplier of 0.46. Now, what's really interesting about this is that this exact same one-step logic applies perfectly to discounts. By multiplying our original $275 by our 0.46 multiplier, we instantly calculate the new value of $126.50. You literally don't even need to figure out what the 54% discount actually is in dollars. You just bypass that step entirely by calculating the 46% of the price that remains. How cool is that? I want you to think of this table as your own personal mental cheat sheet. Just notice the patterns here. A
A 50% increase means adding to 100 to get 150%, which is a 1.5 multiplier. A 20% increase gives us a 1.2 multiplier. But look at those decreases. A 20% decrease means we subtract from 100, leaving 80%, which is a 0.8 multiplier. An 80% decrease leaves only 20% of the original, making the multiplier a tiny 0.2. Once you start recognizing these common real-world multipliers, I promise you, you'll be doing these calculations in your head.
Section 5. The multiplier formula, the ultimate equation.
If you take only one thing away from this entire explainer, let it be this monumentally useful formula. Original value multiplied by the multiplier equals the new value. It is the absolute cornerstone of efficiently handling proportional parts, investments, taxes, and absolute changes.
And the absolute beauty of this formula is that it's completely reversible. If you already know the starting price and the ending price, but you want to find the percentage change, just divide the new value by the original value. For example, if a flight cost goes from an original $2,300 up to a new price of $2,850, you just divide the new $2,850 by the original $2,300. That gives you a multiplier of roughly 1.239. And since 1.239 represents 123.9%, you instantly know the cost experienced a 23.9% increase.
Let's see how this builds in a real-world scenario. Imagine a town's population is expected to rise by 85% over the next 10 years. The original population is our baseline, right at 100. To find the new population, we just add the 85% increase, pushing our new value all the way up to 185. To calculate that in the real world, we just multiply the current population by a massive 1.85 multiplier. It's clean, it's highly visual, and it's perfectly mathematically sound. I'm going to leave you with one final provocative question straight from our mathematical sources, just to test your new skills. Think like a mathematician for a second. If a shop is selling a phone for $80 and increases the price by 10%, but then, a couple of weeks later, decreases that new price by 10%, does the phone return to exactly $80? I'll give you a hint. The answer is no. Use your new multiplier math to figure out exactly what the final price is and why it doesn't just snap back to the original value. Thanks so much for joining me on this explainer, and happy calculating!